The last topic for this part of the module would be relational data. So many times, data is not only in the table, but we also have to take data from different sources and we have to join them. And many times carry out other operations in order to do this so that in the end we can have all data in one set of data that's going to allow us to carry out the analysis and to do machine learning models, and many times you need all the data in one set. So these are the transformation units. Many times we have two different sets of data and we want to join the information of both sets. And that's what we are going to see today. We also have the possibility to use a function to carry out other types of joins, like filtering joins. And when I don't want to add information from another set, but I just want to use some criteria where one variable is found in both sets to filter them, to select the rows that are in both sets of information without adding any additional columns. And there are also set operations which treat observation as elements of one set. Let's say that all the information is in both sets, and I just want to use the ones that are different. And you can also use this link to look for more information. So the unions, this is a way to connect each row in X with 0, one or more rows in Y, for example, like this graph. This means that this could be the Cartesian product of all the options that exist in one or the other can be used to do a union. But you not always need to use all of the information, so that's why we have the different types of unions. The main unions for transformations, the most common one is the left or izquierda, where we keep all the data that's in the data frame or in the set of data that's on the left, or izquierda, and we're going to add the information of the column of the ones that are in the right, just when one variable for identification is common, it's the same one. So you can see that for number 3, there's no one, there's nothing, there's no ID, there's no number 3. So what's going to be joined here would be just this one that's not available. We can also do the oppose, have a union to the right, and this is going to keep all of those that are in the right, and they're going to look for information that comes from the left just when they exist. So in this case, it will be number 4. It's going to be kept as one that's available. The other option would to do an interior union, where only the ones that are common to both are going to be kept. So only 1 and 2 are going to be kept there because 3 and 4 are not available in both sides. And finally, we can do a total union. That's going to keep everything that's in one or the other side. So the most common thing would be the left union or izquierda, but in some cases the others can also be very useful. These are other graphical representations on how these examples can be done. The interior union are the ones that are common in both sets. The total union would be everything. The one is in izquierda or left would be all from the left, and the derecha would be all of the right. And this is also the description of the functions. They have the names in English: left join, right join, inner join, and full join. And this represents all of the options that I just mentioned before. When there are duplicate keys, all the possible combinations would be there from the Cartesian product. So if I have a duplicate key in the right and in the left, all options and all combinations that are similar are going to be created as new rows. So I have two twos. In this case, I'll have four in total. So in general, when this happens, it's probable that there's an error. It's very common to have a duplicate key in one of the sites, generally in the left, but not in both sites at the same time. Usually this tells us that there's a mistake, an error. So whenever there's a duplicate like this, it's good to revise the data so that you have the certainty that this should happen. This is another example on how to do that. So let's say that I have my crop data on the left, and you can see that my crop data, I have one column, which is like a key that says soil ID. This is the ID of the type of soil. We have different numbers, and you can see that there are some duplicate keys. But on the right, I have the data of the soil. It also has the soil ID column, and it has a sequence. There's no duplicates in this case, and there's additional information also, like the type of soil structure, the organic material matter. So I'm going to unite one with the other. So I want to keep the information from the left, and that's why I say I use left join, and I have to identify the column that's going to be used as a key. And this is the result. So for example, look at this one that says soil ID 1, and it comes with the same information from the one in the other side. And that's why we can use this to join or unite the information. This is a very common example of what happens when I have one variable or an ID, and in the other column I have the information of each one. So from the storage standpoint, and also for data collection, it's better to have them this way. But to do analysis, I have to have all the information. So there's going to be a duplication. This was the most theoretical part of the module on how to organize and structure information based on the deep layer and tighter packages. So in the sequence, we'll also continue with more practical activities. Thank you.